A common feature of many moving objects in the real world, and many objects that we have in our sketches, is that they follow some sort of a repeating pattern. We see these patterns everywhere. We see them every day in the rising and setting of the sun. This sequence of images was taken either very far north or very far south, but it shows the motion of the sun over time. The sun goes up and the sun goes down, up and down every day. Of course, in those places where the sun does set, we can see the moon. Not only does the moon rise and set, but the moon goes through phases, and the phases repeat every 28 days. Lots of objects in the world change over time, whether it's a space launch, a person with a sparkler, someone jumping a dirt bike, or just a ball bouncing on the ground. A really easy way to control all of this is to create one or more repeating patterns. The subject of making patterns is huge, and we could have a whole course devoted to nothing but that. Of course, we're not going to do that here. Instead, I'll first give you the essence of how to create a repeating pattern, and then I'll give you a handful of them that will serve as a good starting point for your own projects. The first thing we have to do to make a repeating pattern is to get some sort of a handle on time. There are several ways that we can do this in processing. The simplest way, I think, is to just save the frame count into a variable. So a simple line like this does all the work. T starts at 0, then it's 1, 2, 3, 4, and so on as long as the program runs. Notice an interesting thing here. I've highlighted the word float in red. That's because frame count returns an integer, 0, 1, 2, 3, and so on. The reason this is a float is because later we're going to do things with time. We're going to add to it and we're going to divide. And as we know in processing, if everything involved in a little mathematical expression is an integer, the result is an integer. In order to get things to come out with fractional values, at least one of the things involved has to be a float. I find the easiest way is to just make time the float. And now I can do whatever I want from now on with t, and I know I'm always going to get floating point results. So this is what I suggest to you to keep track of time. There are alternatives, but this is nice and easy. So let's use this variable t to create the heart of a simple repeating pattern. The basic idea is this. This is a timeline. Time is flowing from the left edge of this arrow to the right. And we want a pattern that is going to last for W frames. I chose the letter W arbitrarily. So we just have a pattern that will repeat every W frames. So W frames go by, and then we're back to where we started. W frames go by, we're back to where we started, and so on over and over. So let's mark these off. We're going to have something happening for W frames, and then the exact same thing will happen again and again. So we'll focus just on this first burst of W frames, and I'm going to say that W has the value 4. So I want a 4-frame cycle. So something changes for 4 frames, and then it repeats that change and repeats that change forever. So let's isolate these 4 frames that we really care about. Here are the first 4 frames, and I'm going to show you the 5th frame as well, because that's really the start of the next set. But I want to include that so we can see the entirety of what's happening from 0 to W. This will be a little bit more clear in a moment. So let's number the frames. So each of these vertical bars is the instant at which we're drawing a frame, 0 through 9, and of course this goes on forever. Our cycle is 4 frames long, 0, 1, 2, 3. Frame 4 is the start of the next cycle, 4, 5, 6, 7. Frame 8 is the start of the next cycle, 8, 9, 10, 11, and so on. Now you can think of frame 4 either as the last frame of the initial cycle or the first frame of the second cycle. I think it's much better to think of it as the first frame of the second cycle. So our pattern will run from frames 0, 1, 2, 3, and then it repeats 4, 5, 6, 7, and so on. We can give a name to the frames. It's what we saw in the previous slide where we assigned t to the value of frame count. Now comes the central trick. I'm going to find t mod w. Remember what mod does. In this expression, it says take w out of t as many times as you can while t still remains 0 or greater. In this case, t goes from 0 to 9, and of course beyond, although we're not drawing it, and w has the value 4. So t mod 4 has this pattern, 0, 1, 2, 3, and now t hits the value 4, but t mod 4 is 0 because I can subtract 4 from 4 and I get a value that's 0 or greater. So now we get 0, 1, 2, 3. Now we hit 8. And 8 mod 4 is 0 because I can take 4 out of 8 2 times and I'm left with 0. And so now we have a repeating pattern of numbers, 0, 1, 2, 3, happening over and over again. This is the heart of making a repeating pattern, this little modulo thing. Now to make things a little easier to work with later on, I'm going to divide that number by w. This will give me a number between 0 and 1. So in this case, I'm going to divide all of those numbers, t mod w, by 4. So I'm going to get 0 quarters, 1 quarter, 2 quarter, 3 quarters, and then back to 0. 0 quarter, 1 quarter, 2 quarters, 3 quarters, back to 0. So let's plot this and see what it looks like. Here's a little vertical axis that runs from 0 to 1, and I'll plot the first few values. So there they are, and we can see that the value goes up smoothly, and then at frame 4, it drops back down to 0. So let's connect the dots. This is a perfectly reasonable way of drawing this. We're just drawing a straight line through each dot. But it turns out that this is not the conventional way. This isn't the way it's usually drawn. Instead, we usually draw this way. We extend the line vertically until it hits the 1, and then it drops right back down to 0. So if we were to repeat this drawing over and over, because the cycle repeats over and over, we get this pattern. It slopes up and drops back down to 0. Slopes up and drops right back down to 0. So let's take a look at just the first 4 frames where this pattern repeats. That's the essential chunk of pattern that just happens over and over again. I'm going to give a name to the vertical values that come out, these values between 0 and 1. I'm going to call them V. So now I'd like to write down the expression for V. Well, we have that. That's exactly what's above it in red. It's T mod W divided by W. So here is the heart of making a repeating pattern. This is the basic idea. We take a look at a single chunk of this pattern. It lasts for W frames. And by writing V equals T mod W over W, we get back a value of V that changes from 0 to 1 over time. This particular pattern is called a sawtooth pattern, because it kind of looks like the teeth of a saw when viewed from the side. Let's take a look at the sawtooth pattern in action. Here's the sawtooth pattern, along with a little vertical red bar that's moving from left to right. That's my time scrubber. Let's use the value of V from 0 to 1 to control the motion of a ball. So when V is 0, the ball is at the bottom of this box. When V is 1, the ball is at the top of the box. And of course, when we fall off the end of the pattern, the ball jumps immediately from the top to the bottom. Let's take a look at some other visualizations using this value of V. Here I'm filling in a wedge, and the value of V is the angle that marks the end of the wedge. And again, we can see after the thing is full, at 1, it jumps right back down to 0. Here's a teeter-totter. It begins by leaning it towards the left, and as time goes on, it goes to the right, and then when we hit 1, it jumps right back to the left. Here's a pendulum swinging from left to right. The value of V is controlling the angle of the pendulum. So we start off at the left and we just move smoothly to the right, and then we jump right back. Of course, this jumping motion is not perfect for a pendulum. We'll deal with that later. Here's another example. I'm changing the size of a square and a circle. The square is getting larger and the circle is getting smaller, both at the same time. Here's another set of visualizations. In the upper left, I'm blending colors from the beige color on the left to the green color on the right. In the bottom left, I have a little circle that's moving along a random Bezier curve. And by clicking in here, I can choose other Bezier curves. There's one with a nice loop, and we can see that the circle starts at the beginning, swings around, goes to the end, and jumps right back. Finally, on the right-hand side, you can see I'm controlling 2 things at once. I'm taking the word plums, and I'm rotating it and scaling it at the same time, using the value of V to make the thing bigger and more rotated. I can change the number of cycles I'm using with my keyboard, and so I can make things go much more slowly. Let's take a look at the other set of visualizations, and you can see things go nice and slow. Or I can make them go much faster by making the value of W smaller. All I'm doing here is changing the value of W, making it a smaller number. This is how I write these sorts of things in my programs all the time. I just pick a value of W and then I change it until it looks good to me. So this is the essence of how we create repeating patterns. It's this T mod W stuff. By using the mod, we're able to get back a repeating series of numbers, and then we massage those into some form that gives us an interesting pattern. In the next video, I'll give you the recipes for 5 useful patterns that you can use as a starting point for your own patterns.